Hi there, my name is Saeid. I'm with Prep 101. In this primer, we will talk about basic of trigonometry and CAS rule. This is an important topic that you need to know to grasp the idea of inverse trigonometric function that is discussed in Math 186 at U of T, especially before the first midterm. Okay, let's get started.
Okay, so when it comes to trigonometry, the first thing that we talk about is the right triangle. So imagine you have a right triangle and this angle here is theta. Now, we need to define trigonometric ratio. So by definition, if I have this angle theta and I call this side, let's say, opposite of that angle, I call this side adjacent of that angle, and I call this side hypothesis in this right triangle. So by definition, sine of this angle is defined as opposite side divided by hypotenuse. Cosine of that angle is defined as adjacent over hypotenuse. Now this could be any other angle. It could be this angle in the triangle. So when you want to define cosine of that angle, it will be opposite of that divided by hypotenuse. Tan of angle is defined as sine of that divided by cosine. Or if you simplify, it would be opposite divided by adjacent side. And cotan is defined as cosine over sine, or 1 over tan. That simply means we need to flip the previous fraction, so that would be adjacent over opposite. And we also have secant theta, which is 1 over cosine, that would be hypotenuse divided by adjacent. And we have cosecant theta, which is 1 over sine theta. So you see the sine theta, we just need to find the reciprocal of that or flip this fraction. So that would be hypotenuse over opposite. So once we know this definition, we have something called unit circle that I'm going to draw that. So the unit circle, as the name indicates, is a circle whose radius equals 1. So imagine you have a circle in the xy plane and the radius of that equals 1. So that means this is 1, this is 1. The radius of this circle at any point equals 1. So in this triangle, if I pick a point, say here, this point has an x coordinate and has a y coordinate. And if I connect this to the origin, I have an angle theta here. So as you see, this is a right triangle. So I should be able to define those trigonometric ratios that I mentioned earlier. So again, by definition, the x coordinate of this point, which is right here, is actually cosine of that angle. So x is actually cosine of that angle. And the y coordinate of this point, which is here, I can also show that here, the y coordinate of that point is sine of that angle. So as you see, if I want to write Pythagorean theorem, you see that the radius of the circle is 1, so the hypotenuse is 1. I have the x coordinate to the power of 2 plus the y coordinate to the power of 2 would be equal to the hypotenuse to the power of 2. This is actually the equation of that circle. Now, if I write the equivalent of x and y, that would be cosine squared of theta plus sine squared of theta. That would be equal to 1. So this is one of the most important identities in trigonometry, and now you know where it comes from. It's actually just Pythagorean theorem in the unit circle. The other thing I want to talk about here before we do one example is the CAS rule. So you remember the trigonometric ratios that I talked about here. The trigonometric ratios can be positive or negative. So according to CAS rule, which I write it here, so it actually starts in the fourth quadrant, so that would be CAST. What this means is that in the fourth quadrant, actually let's start with the first quadrant. In the first quadrant, all trigonometric ratios are positive. In the second quadrant, sine would be positive and the rest of them would be negative. And of course, when sine is positive, you see that cosecant is also positive. So when I say the other ones, I'm talking about these four. These are the primary trigonometric ratios. In the third quadrant, tan is positive And obviously cotan is also positive, right? Because cotan is 1 over 10. And in the fourth quadrant, it's only cosine that is positive. So you can remember this CAS rule, and that will tell you the sign of trigonometric ratios in each quadrant. Now, let's do a couple of examples. So you can get a variety of examples here. I'm going to do one, and that's a type of question that you're asked to find trigonometric ratios in other quadrants. Now note that in the first quadrant you need to know the special angles. That would be 30 degrees, 45 degrees, and 60 degrees, and 90 degrees. And you need to know their trigonometric ratios. So you need to know sine of that, cosine of that, tan and cotan of that. Assuming that you know that one, let's say there is a question that asks you to find sine of 5 pi over 6. So I mean, we're not going to use a calculator here, and that's actually very common in first year engineering courses and first year science courses, that in many courses you're not able to use a calculator. So we're going to use the unit circle here. I'm just going to quickly draw the unit circle again. So first of all, we need to locate where this angle is. So we need to know whether this is in the first quadrant, second quadrant, third quadrant, or fourth quadrant. So now, where is this angle? The angle is in the second quadrant, because 5 pi over 6 is actually pi minus pi over 6. So it's actually here, and this is pi, so that would be right here, and that's 5 pi over 6. Now, the question here is, okay, now we know where this angle is, but what is the corresponding angle in the first quadrant? So if you kind of reflect this, the other side, this would be the equivalent, or the corresponding angle, I would say, in the first quadrant. That's actually pi over 6. So compare these 2 points. I mean, this point right here and this point right here. And ask yourself this question: do they share any coordinates? Or what is the relationship between their x coordinates? What's the relationship between the y coordinates? Because we know that the x coordinate of these 2 points is basically the cosine of that angle, and the y coordinate is sine of that angle. So I can write sine of 5 pi over 6. That would be the y coordinate, which is right here. That's the y coordinate. You see that the y coordinate of these 2 points are the same, which indicates that sine of 5 pi over 6 is actually sine of pi over 6. So the sine value is the same for them. And assuming that you know sine of pi over 6 because it's in the first quadrant, you need to know the special angles and their trigonometric ratios in the first quadrant. The answer to this would be 1/2. So this is how you can find the trigonometric ratios in other quadrants. Now, let's say the question asks you, let's say that's another question that asks you to find cosine of 5 pi over 6. So we can do the same thing. So we can look at the unit circle up there and say, hey, what is the relationship between the x coordinate of these points? So you see that this is the x coordinate of 5 pi over 6, and this is the x coordinate of pi over 6. You see that they're just opposite of each other. So they're the same in terms of magnitude, but their signs are opposite. So you can write cosine of 5 pi over 6 is equal to negative of cosine of pi over 6. You can see that these are just negative of each other. And assuming that you know cosine of pi over 6, because it's in the first quadrant, the answer will just be negative, and then cosine of pi over 6 is root 3 over 2. So this is how you can find trigonometric ratios in other quadrants, assuming that you know the corresponding angle in the first quadrant. Now, let's do one more example. Let's say you want to find sine of 7 pi over 6. I'm going to locate 7 pi over 6. 7 pi over 6. So 7 pi over 6, I can write this as pi plus pi over 6. So it's actually in the third quadrant, so it's right here. And if I ask myself this question, what is the corresponding angle in the first quadrant? It's actually right here. So this is pi over 6 again. Now the question is, what is the relationship between the x coordinate of these 2 points and the y coordinates of these 2 points? As you see, the x coordinates are opposite of each other. The y coordinates are also opposite of each other, because this is the y coordinate of this, and that's the y coordinate of the other one. So that means sine of 7 pi over 6 is just sine of pi over 6 with a negative sign in front. Again, assuming that you know sine of pi over 6, because pi over 6 is in the first quadrant, the answer will just be sine of pi over 6, which is 1/2. So the answer would be negative 1/2.
I hope that you found this useful. If so, check out more foundations of first year calculus in the playlist. Also, make sure to join our Facebook Study Hub for this course. You can find the link in the description box below. Finally, I hope to see you at my prep session. I will show you how to solve midterm and exam problems and how to do that with confidence and how to ace your midterm and exam. Remember that many prep sessions for midterms are free. Visit prep101.com for more details. Thank you for watching.